Hello everyone, welcome back to my YouTube channel. In this video, I am going to solve electric circuit based questions from electricity chapter. Many students feel that circuit based questions are confusing and difficult. So, today I will explain them in simple and easy way. Let's begin the video. Our first question is find the equivalent resistance between point A and B. So you can observe all the four resistors having same resistance of 3 ohm. So here 3 ohm resistor is connected between point A and B and two 3 ohm resistors are connected at the point C. So here C is the common point for all the resistance. Observe the circuit carefully. Here, two 3 ohm resistors are connected at point C are in series. So, substitute this 3 ohm and 3 ohm in series combination formula. Then, Rs is equal to R1 plus R2. So, R1 value and R2 value is 3 ohm and 3 ohm. 3 ohm plus 3 ohm gives 6 ohm. Okay, the total value of these two resistors is 6 ohm. Now, so from this circuit diagram you can observe 3 ohm resistor, 6 ohm resistor and another 3 ohm resistor. These three are connected in parallel. So we know about parallel combination formula. What is that? 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Just you substitute these three values 3 ohm and 6 ohm and another 3 ohm in the formula. We'll get 1 by 3 plus 1 by 6 plus 1 by 3. So if you take LCM for these three, you will get 6 as a 6 is the LCM. In numerator, so we'll get 5. 1 by Rp is equal to 5 by 6. Then Rp becomes 6 by 5. If you simplify this fraction, you will get 1.2 ohm is the answer. Okay students, now let us solve this question step by step without any confusion. In this question, we are going to find the equivalent resistance between A and B and also equivalent resistance between C and D. Before solving, always remember one thing. First, simplify the circuit as much as possible. Let us first focus only on the part of circuit between A and B. If you carefully observe the circuit, all the given resistors have the same value, that is 2 ohms. Between terminals A and B, three resistors of 2 ohm each are connected one after the other. Current has only one path to flow through these three resistors. They are connected in series. So we know about series parallel combination formulas. So in series combination, series resistance is equal to R1 plus R2 plus R3. So we are finding resistance for these three resistors, that is 2 ohm plus 2 ohm plus 2 ohm. It gives 6 ohm. Okay. Now you see between A and B, one more resistor is connected. That is 2 ohm resistor. So how much we got answer after solving this series combination? We got 6 ohm. This 6 ohm is parallel with 2 ohm resistor. This 6 ohm resistor is connected parallel with another 2 ohm resistor. Both resistors are connected between the same 2 points, that is A and B. Now use parallel combination formula. So that is 1 by Rp is equal to 1 by R1 plus 1 by R2. Now substitute the values. R1 by Rp is equal to 1 by 2 plus 1 by 6. Now LCM is 6. So what we will get? 1 by Rp is equal to, in numerator, 3 plus 1. That is 5. 5 by 6. So 1 by Rp is 5 by 6. Then Rp is 6 by 5. After simplifying this fraction, we will get 1.2 ohm. So this 1.2 ohm is the equivalent resistance between A and B. Okay. Now let us find the total resistance between C and D. So we know 1.2 ohm is the equivalent resistance between A and B. Two more resistors are connected to AB. Now we can see three resistors. So one is AB, another one is 2 ohm resistor and one more 2 ohm resistor. These three resistors are connected in series because current flows through them one by one. We know series combination formula. So we can write RCD is equal to R1 plus R2 plus RAB. Just you substitute the values 2 ohm plus 2 ohm plus 1.2. So what will be our answer? 2 ohm plus 2 ohm is 4 ohm. 4 ohm plus 1.2 is 5.2 ohm. Okay, let us move on to the next question. Calculate the equivalent resistance in the circuit. In this case, there are 3 resistors and each resistor has same resistance of 3 ohm. So let me draw the circuit once. Okay, here 3 resistors. Each resistor has the same resistance of 3 ohm. Now observe the diagram carefully. Points A and B forms the base of the circuit. One 3 ohm resistor is directly connected between A and B. To simplify this circuit, imagine pulling point C downwards. So when we do this, the circuit becomes clear. The two resistors meeting at the point C are now seen to be connected in series. So I'll rewrite the circuit diagram. Here we can apply series combination formula for these two 3 ohm resistors. 3 ohm resistors are connected in series. So just you apply these values in the series combination formula. Rs is equal to R1 plus R2. 3 ohm plus 3 ohm gives 6 ohm. So at the point C we got 6 ohm. Then this 6 ohm resistor and 3 ohm resistors are connected in parallel. Just you substitute these values in parallel combination formula. So then parallel combination 1 by Rp is equal to 1 by R1 plus 1 by R2. 1 by Rp is 1 by 6. Then 1 by 3. Take LCM for 6 and 3. It will give 6. The numerator will get 3. 3 1 by Rp is equal to 3 by 6. Then Rp becomes 6 by 3. If you simplify this fraction, you will get answer 2. Equivalent resistance or effective resistance between A and B is 2 ohm. Okay, let us move on to the next question. Calculate equivalent resistance in the following cases. So observe the circuit diagram. So here you can see 4 different points P, Q, R, S. 2 resistors are connected between P and S. 2 more resistors are connected between Q and R, and 1 resistor connected between P and Q, and 1 more resistance is connected between S and R. So let me first we'll simplify resistance between PS and QR. So P and S, if you observe resistance between P and S, these two resistors are connected in series. Here we can use series combination formula. RPS is equal to R1 plus R2. So substitute the values. R1 is 2 ohm, R2 also 2 ohm. 2 ohm plus 2 ohm gives 4 ohm. Now let me solve a resistance between Q and R. So again use series combination formula. RQR is equal to R1 plus R2. So 2 ohm plus 2 ohm gives 4 ohm. Let me rewrite the circuit once. Now between P and S, resistance value is 4 ohm. Between Q and R, resistance value is 4 ohm. Between P and Q is 2 ohm. S and R is 2 ohm. Here 2 ohm, 4 ohm and 2 ohm are connected in series. We can directly substitute these three values in series combination formula. So that means R1 plus R2 plus R3. 2 ohm plus 2 ohm plus 4 ohm gives 8 ohms. So now this 8 ohm resistor is parallel with 4 ohm resistor. If you simplify this 4 ohm and 8 ohm in parallel combination formula, we'll get 1 by 4 plus 1 by 8 is 3 by 8. Then 1 by Rp is 3 by 8. Rp becomes 8 by 3. So if you simplify 8 by 3, you will get 2.6 ohms. The total effective resistance between A and B is 2.6 ohm. I hope you have understood how to find equivalent resistance when it is given in an electric circuit. In the next part of the video, we will solve few more questions based on electric circuit focusing on electric power. I hope you understand these numericals clearly. If you found this video is helpful, please subscribe to the channel and share this video with your friends. Thank you everyone.